Dear students, today we are going to learn about chapter number 7, permutations and combination. Ngasi akhuna tamdurise chapter number 7, permutations and combinations haibasini ko. Permutation haibadi arrangement haibani. Permutations means arrangement. Adu arrangement singse kamaina puthokpa yage haiba rule se tamse ko. Example hana yengase. First let us consider an example. Given three different letters, say A, B, C. Nangon the different letters ahum pira A ne, B ne, C ne. How many different three letters word can be made by using these letters? And now we are going to find all the possible words consisting of three different words. Three different letters nangi word tongan the word me amam putoka doineba. Nangi word singsi the letters kya yauba letters ahum yaw doineko. And first write all the possible arrangement made by these three given letters. Nangon the piriba letters ahum sina semba. Tongan ba arrangement nan putoseko. Ahanba the A layer A na first the B C A layer ko interchange the position of B and C, we get A C B. Then write B A C interchange the position of A and C, we get B C A. Then write C, write A and the B, then interchange the position of B and A, we get C B A. Sumain tawraga A na mamang amuk thangba, B na mamang amuk thangba, C mo mamang thangba ina tongan na ire ko. Jadi siguma total possible arrangement se kya phangba ngami taruk phangba ngamdra. And so there are 6 different three letters what nangi word se the letter ahum yaw 6 different words se puthokpa ngameba ko. Kana na form tawi harakanda A ne, B ne, C ne sumain tawraga tongan ba arrangement meam puthokpa se kai kawi harakanda permutation ni ko. Permutation ki total possible arrangement se puthoknaba gi damakta rules kya lay. Rules tani lay ko. Number 1 addition principle and number 2 the multiplication principle. Addition principle ki statement yengse. Now we are going to read the statement of addition principle. If an operation can be performed in m ways, and if another mutually exclusive operation can be performed in n ways, then either of the two operations can be performed in m plus n ways. Ahanbada nangi operation nama m ways da perform tawba ngamaba, and another mutually exclusive operation can be performed in n ways, then either of the two operations can be performed in m plus n ways. Mutually exclusive operations side kaino. Mutually exclusive operations are such that only one operation can be performed at a time. Operation ama se amukta da pangthokpa ngamba means nangi operation ama se complete oiduni ko. Ngasa ina ABC haiba word sijinaraga semba tongan ba arrangement putho haiba matamda ABC haiba se different arrangement ama ne ma se operation ama oiduni. Sisu tongan ba ama oidra magisu operation ama sisu tongan bam oi sisu operation am ne ko. Aduna total possible arrangement haiba kana moi me amse plus ta widana haiba dinangi operation haiba se complete arrangement ama oidune. Sisu complete arrangement ama oiba sisu complete incomplete na tabu ko. Aina AB dang oi tardi incomplete ore atopa letter sama changidana. Aduna nangi mutually exclusive operation hai tardi operation amamam sina complete arrangement amamam oiba se kai kawe ko na mutually exclusive kawe ko. Adugo mutually exclusive mayam do either of the two operation can be performed in ways kya da perform to we haiba m plus n. Addition principle na mean to se kaino nangi possible arrangement se loi itho ne aduga count to ko. Adu nangi addition principle ne mathangda multiplication principle. The statement of multiplication principle is if an operation can be performed in m ways, and if after this operation the second operation can be performed in n ways, then the number of the ways of performing both the operations simultaneously is m by n. Nangi operation je hana m ways da mu yagre ko. Adu loraga mathang da mu kaida operation je n ways tamu operator, but then the number of ways of performing the operation simultaneously is m into n. Chigi han bagi example sida ABC ACB hena tongan laitra. Kona 3 letters word am semadi example oni ABC haiba kana vacant place se kya laini. Vacant place se ahum laini ko. Vacant place 1, vacant place 2 and vacant place 3 ne. Si vacant place amamam fill up to was operation amamam ne. dudi ai operation kya leire operation ahom leiko si ahan bagi 3 se kamaina la ino haraka nangi object se kya le home leitra first vacant place, second vacant place and the third vacant place. These vacant places are to be filled up by these 3 letters niko. In example dugi matungina takpane ahan bagi vacant place nang fill up tawbo pame. First vacant place can be filled up by any one of the 3 objects. It may be A, B or C. Home segi manungda amana fill tawbo yadra doi tardi total possible ways se kya leire. Total possible ways of filling this for first vacant place is 3. If the repetition is not allowed, nang repetition yaram dragadi have the A have yadabadu oida targadi. Next the A thamgi tardis the A lakpa yara roiba. Duna total possible nangi all letters se 3 na dra 3 dagi 1 laukthokradi 2 pange ko. Duna 3 leramba se 2 dam hantagrani 1 dam hantarakani ba. Multiplication principle se kamain paga duino mo yengse ko. If an operation can be performed in m ways, then if after this operation the second operation can be performed in m ways, then the number of the ways of performing both the operations simultaneously is m into n niko. Si ahanba operation ni si second operation ni si third operation ni si hana operate tawraba matungda si mung lakadaba si loiraga sumaina amana amada depend tawna doine maise ko. 3 hana fill up tawgre 3 have se kaino nangi object ahum leibanina there are 3 ways of filling this vacant place. Sigi vacant place fill up tawba kana ways ahum leigrani. If the objects cannot be repeated, then we are left with 3 minus 1 is equal to 2 objects only. And these second places can be filled up by any one of the 2 remaining objects. Nangi remaining objects ani dudagi amana fill up tawba yani ko. Ways kya legani mage? Ways ani legani. Sidamuk ama fill up tawgi tardi 2 dagi minus 1 khaidokradi kya tare 1 tadra. Adugi lemhoriba 1 se nangi ahum suba vacant place to the thamganeba. Aduna multiplication rule dadi sigi operators mayam sigi marakta into lakaneba ko. Sina first operation, second operation and third operation. 3 into 2 into 1 6 tare ko, and total possible arrangement made by these 3 letters is given by 3 into 2 into 1 is equal to 6 main lerani. Addition principle na kai haba addition principle ge di nangi oibiya ba arrangement mam se loi ithoba matung da plus tawba ko. Multiplication rule na nangi vacant place se khangdokpa. Vacant place nangi object se 3 vacant place have the 3 to form a word consisting of 3 words 3 letters I tar the vacant place ahum leirani ba consisting of 4 I tar the vacant place se kya thorakani marisi guma vacant place amamam fill up tawba se operation amani moise first second third to the depend tawna ne ba ko sigena multiplication se ne important oi beheli side hayeng nang na value chawrakan apply tawba yagani. By multiplication principle, total possible arrangement made by these 3 letters is given by 3 into 2 into 1 6 tare ise ngasai koina addition panba matam da si addition rule ni ko addition panba matam da su possible arrangement se lo ithoga plus da weba ada su 6 phangra hojing multiplication panba kan da su kya phange 6 phange ko. Example sida muyeng se a coin is tossed 2 times and the outcomes are recorded. How many possible outcomes are there? Nangi coin ama se anirak lange outcomes are record tawre. How many possible outcomes are there? Use number 1 addition principle and number 2 multiplication principle. Ahan bade addition principle use tawro mathang dana multiplication use tawro hoibo ko. Addition principle use tawbo se ani yengse ko. When a coin is tossed twice, we have the following possibilities. Addition principle dadi koina oibiya possible outcomes mayam se loi igadamni ko. When a coin is tossed twice, we have the following possibilities. Number 1, all the 2 outcomes are head. Head anangi outcomes animak se head tabe ba hais ko. Total possible arrangement is 1. There is 1 head and the 1 tail. In this case, we have 2 arrangement, that is hasty and the th. Hasty means the first coin shows head and the second shows tail, and the first coin shows tail and the second shows head. Sumaina ahan ba the head thokpa mathang the tail thokpa ahan ba the tail thokpa mathang the head thokpa sumain taraga possible ani leire ko. Possible arrangement se number 3, all the outcomes are tail. All the possible outcomes are tail ni t taradra 1 phange. Then by the addition principle, total possible outcomes is given by 1 plus 2 plus 1, which is equal to 4 tareko. Nangi addition bu haradi oibya ba arrangement ma'am se lo itho aduga plus tawgadaba. Then we are going to find the total possible outcomes by the multiplication principle. Multiplication principle already kamaini used to bayani yangsiko. When a coin is tossed, there are two possible outcomes, that is head or tail. Nang na coin na malangagadi, possible outcomes ani lagan head or tail oigadaba. When a coin is tossed again, and there are again two possible outcomes. Coin amasum lang bahai base kaino possible outcomes se ani laigani ko. Total outcomes 2 is the total possible outcomes in the first row, and this 2 is the total possible outcomes in the second row. And so 2 into 2 sine m ni ko sine n ni, m into n will be equal to 4. Sumaina lakani ba. If a coin is tossed 3 times, then total possible outcomes is 2 into 2 into 2. Nangi draw masing khudingi total possible outcomes e hantarakte hantarakpra 2 2 adum leidoini ko aduna sida nang 2 2 2 hana fill up tawragadi 2 2 tare anira khaktang langagadi 2 into 2 4 sumaina. Nangi total possible outcomes sing se puthokpa yaduini ko. Now we're going to solve exercise 7.1. 7.1 saying siko. Exercise 7.1. How many 3-digit numbers can be formed from the digits 1, 2, 3, 4, and 5, assuming that number 1, the repetition of digit is allowed. Repetition yaiko. Number 2, the repetition of the digit is not allowed. Repetition yabe and repetition yadaba ina muglai. Nangi arrangement sing sida. Repetition hai de hanjin hanjin iba yaba ko amana hanjin ba yadaba haiba. Hose ko na form tawdu se kaino. Here we are going to form all the possible 3-digit numbers by using the digits 1, 2, 3, 4, and 5. 3-digit numbers hai tardi nang second place kya lairani. Second place ahum leibam to eko. Chumani unit place, 10 place, and the 100 place laiduin. Number 1, if the repetition of the digit is allowed, the units place can be filled up in 5 ways. Ngasagi nangi digit se 1 ne, 2 ne, 3 ne, 4 ne, 5 ne ko. We have 5 digits. Then by using these 5 digits, we have to write all the possible 3-digit number. 3-digit number oitaragadi, we have unit place, 10 place, and 100 place leibam to eko. Repetition yar this the 5 thamba, this the 1 thamba do, this 1 thamba yani, this 1 thamba yani, this 2 thamba do, this 2 thamba yani, 2 thamba yani, 2 2 2 sne number am form to doine ba. Aduna nangi possible outcome se masing hengalaka doine ko. If the repetition of the digit is allowed, the units place can be filled up in 5 ways. Haibadisigi unit place any one of the 5 digits na fill up the this unit place can be filled up by 1 or 2 or 3 or 4 or 5, and there are 5 possible ways of filling this vacant place. Nangi vacant place filled over the 5 ways later ko. And the 10th place can be filled up in 5 ways since the digits can be repeated. And also this last place, 100th place, can be filled up in 5 ways. 5 ways ta dum yadra yaiko. And therefore by the principle of multiplication, total possible outcomes is equal to 5 into 5 into 8 is equal to 1 to 5 tareko. Nang na addition pan ge hai taragadi kaidawne, we have to write all the 3-digit numbers. 3-digit numbers but we have to write all the 3-digit numbers formed by the given 3 digits 1, 2, 3, 4, and 5. Then count all the possible arrangement ma'am de lo in count tawgada adudi masing yama aga de khoi convenient oibra oide ko aduna multiplication rules in a hen convenient oi. Number 2, if the repetition of the digit is not allowed, repetition yadragadi nang sigi unit place fill up tawbakanda 1, 2, 3, 4, 5 haina ways manga le rambado. Example is the 1 thamgre ko. 1 se nang na unit place the tham guitar di 1 cannot be repeated in 10s place and 100 place. If we place 1 in the units place, then this 1 cannot be repeated in 10 place and 100 place. So we are left with 5 minus 1 is equal to 4 digits. 4 digits le hauri ko. See 4 digits se use tawraga 10 place se mu fill up tawduini. See 4 yogre 4 dagi ama lawthokradi kya ta amka 3 tadra tuna last ki 100 place se 3 de lakani but 3 4 5 have se ways na tani ko nangi fill up taw bya base If the repetition of the digit is not allowed, the units place can be filled up in 5 ways. Repetition yaragadi hanjinbe, repetition yadragadi masing se amamam hantarauko. The tens place can be filled up in 4 ways. The hundreds place can be filled up in 3 ways, and therefore total possible 3-digit numbers is equal to kya tare 3 into 4 into 5. Sumay lahani total possible 3 digits numbers is equal to 3 into 4 into 5. 60 tare ko. Next question is question number 2. How many 3-digit even numbers can be formed from the digits 1, 2, 3, 4, 5, and 6 if the digits can be repeated? Nang hauzik form tawdu se kaino 3-digit even numbers ngatani. Kana sijinaraga 1, 2, 3, 4, 5, and 6 ko. And the digits sing se kaida way, digits sing se repeat way, and digits can be repeated. Here we are going to form all the possible 3-digit even numbers. Even numbers by using the digits 1, 2, 3, 4, 5, and 6 by repeating its digit. Digits can be repeated. Nang digits se repeat away are ko segi kesida adudi kana form taway ani simu yengase. Since a number is said to be an even number, nangi number ama se even number oeba if the units place is occupied by the even digits only. Nangi number ama even number have se kaino unit place to the even digits ma'am se later kanda yabaneba. Do na given even digits set 2 ga 4 ga 6 ga tare ko. Nangi unit place se kya khatang na fill up to biane. This unit place can be filled up by either 2 or 4 or 6. Si khatang oineba. Kay gino hairadi even number tana bay damakta ko. Since a number is said to be even if the units place is occupied by the even digits only, and so the units place can be filled up in 3 ways. Since the digits can be repeated, the tens place can be filled up in ways kya diyan 6. Nangi total number of digits is 6 ni ko. 6 adum phange. And similarly, the hundreds place can be filled up in 6 ways. Ways kya da dumya 6 da dumyadra. Say 3 da mele, say 6 da mele, say 6 da mele. 6 kai de la ino. Sige total possible digits e nangon da piri se. Si 10 plus se 1 tamaswe, 2 tamaswe, 3 tamaswe, 4 tamaswe, 5 tamaswe, 6 tamaswe adra. Adugi ways to ni ko. The 6 ways haris repetition ya bani na masing se hantarakte ba. Sisu dum kai dele 6 ways ta dum lai ko. Then nangi total possible ways se 6 into 6 into 3. Then 108 sinapira ni. Next question is question number 4. How many 5-digit telephone numbers can be constructed using the digits 0 to 9 if each number starts with 67 and no digit appears more than once? Nangi digit se hanjin be ade ko. Handakti nangi digit se hanjin be adre. Hauji aina form tawdu se kaino 5-digit telephone number ne. 5-digit telephone number starts with 67. Kaina hoba 67 na dum hoba ko asmaina. Telephone number mangagi mapamam pire ko. First, second, third, fourth, and fifth haina pire. First se 6 na dum thamgadaba. Second se 7 na dum thamgadaba. Dudi akoida fill up tawdu se vacant place ahum khatanga re ko. Now here we are going to construct all the possible 5-digit telephone numbers by using the digit 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 without repeating its digit. Nang repeat digit sing se repeat we abra. Ya deko this is repeat away the taragadi nangi letters sing se decreased by 1 amam hantaragadav ne digit se ko. Since its number starts with 67 nangi number khuding makse kaina hogadava 67 hogadava maramna, so the first and the second vacant place can be filled up in one way respectively. Si 6 na dum occupy tawgrani, si 7 na dum occupy tawgitardi atopa letters thambaya gadra. If the each letter starts with 67, then the first place is to be occupied by 6 only and the second place is to be occupied by the 7 only. So there is only one way of filling these vacant places. Nangi vacant places fill tawbo matam the way se ama khatamok phangeba 6 ka 7 ga way amamam khatang atopa number na occupy tawbo abra. Yadre ko sima khange adu mathang da ina fill up tawdu se 3rd ka 4th ka 5th ka ni ko 0 1 2 3 4 9 haiba se total possible digits se 9 ne sidagi 6 7 lokthok ki tar di 8 na tra. since the digit cannot be repeated, so we have to subtract 2 from these 10 digits. If 8 later, we are left with 8 digits, and this third vacant place is to be filled up by this remaining 8 digits. Sigi 8 digits singsina nangi third place fill up tawgadabane. The third place can be filled up in 8 ways. Since the digits cannot be repeated, so the fourth place can be filled up in 7 ways. Amamamsum hantharani ko. And the fifth place can be filled up in 6 ways. 8 to 7 the muhantarani, 6 the muhantarani. And by the multiplication principle, total possible 5-digit numbers, 5-digit telephone numbers. See the telephone happy ko. 5-digit telephone numbers is equal to 1 into 1. First ka second ka gi 1 1 lere ko. Mathang gi 8 ama lae. Mathang the 7 ja hapo. Last the 6 lere 3 3 6 haina la ani ba sumaina. Nangi 5-digit telephone numbers starting with 67 se 336 sumaina phangani ba. For today, let's end here.